guardian, if you're doing cruddy in class, saying, hey, you know I record every one of my lessons, and like, oh, you do? Oh, my child didn't even know that. Because you're not listening. Okay? Yeah, I record every day. And I say it every day. Yeah, so just imagine that. Somebody sat here for an entire semester and heard me say something every day, because it's that important to know that it's there for you. Okay? Come on, you just had to take a wander. You didn't have to stay out that too long. All right. Let's take a look at problem number 1. Okay, this was what we had been working on last semester. Agree? We are finishing up the semester. So we taught you 3 different processes to do this. We did graphing. But what some of the things graphing wasn't good was, we don't always have really good tools. Sometimes our answer might be off our grid. Sometimes our answer might be decimals or fractions. So graphing is a valuable tool, but it gives us visual representation, but it's not always good. But then we talked about the elimination method and substitution. Anyone want to take a shot? Anyone remember how I could solve for my x and y value on this problem? Yeah.
You have to add those equations, but there's already a reciprocal.
You're right. I like it. I like what you're saying. So the answer is we're going to add the equations together. And something to note, if I add these equations together as they sit, notice I have a positive 6y and I have a negative 6y. So if I add if I subtract two things that are the same thing from each other, what does the result have to become? 0. They cancel each other out. So these add together. So 6 minus 3, I have $6 in my pocket. Something costs $3. 3x left. These become nothing, right? And then if I add 0 and 15 together, geez, it's been a while. 15. How do I get x? Divide by 3. Look at that. Y'all remembered something. All right, so my x value to my answer is 5. What is my y value? How do I find my y value? Plug it in. Yeah. All right, so I'm going to take this 5 and I'm going to plug it in either to that x or that x. In this case, it doesn't matter. Now, sometimes there is a process that makes it a little easier. I would probably choose to plug it into the top one because I don't have any negative signs. Okay, I'm going to get the same answer if I plug it in the bottom, but I might choose to plug it into the top because there's not a negative sign in sight. So I'm going to plug it in there. So I'm going to get 6. This is where x used to live. What's going to go in there now? The 5. And let's see, 6 times 5, 5, 10, 15, 20, 30. 30, good, okay. And then how do I solve this for y? Say it. Subtract 30 from both sides, good. Those cancel, 6y equals negative 30. Divide by 6, divide by 6. Help me out. Yeah. So I now have a thought process in order to get a solution to this problem. This type of thought process is a very logical, progressive event. You're looking at things. You look at this problem, and if it says solve, you have 3 things in your wheelhouse in order to do this. You have graphing. Well, I probably wouldn't do graphing because the cover method on the top one is going to give me 0, 0. And what's your other point? I don't know. Okay? The other one, the cover method, is going to give you a fraction when you solve for the y. So graphing is not going to work real well. Substitution means I have to get a letter by itself to equal something else. Well, that seems like a lot of work. Well, elimination. So you've gone through a progression of, should I do this or this or this? In real life. Should I go really, really hard doing this? Should I go with this route or should I go this route? It's all going to give me the same location. Well, if this route is a simpler way to get there, do it. Okay, only math people make it the hardest route. Do you remember seeing this? Is this something that you recall? Now, let me go down to number 9. Let me go down to number 9. Come on. We've only been back in school so long. So on number 9, so I guess we could try and graph it, but graphing is going to give me fractions on the x on the top one. I could try and do elimination, but my x's and y's aren't on the same side. So I'm going to look at substitution. I'm going to look at substitution. So what do you think I should, I circled 4x minus 12. What do you think I should do with the 4x minus 12? Yeah, I'm going to go into the other equation where I have a y, and I'm going to stick it in that spot. So I'm going to get 3x plus 2. A y was here. A y is no longer going to be there. What's going to be there? 4x minus 12. Okay. So it looks like I can distribute here. Let's see. 2 times 4, that's 8. 2 times negative 12 is negative 24. We get to there. What do you think I should do in that purple region? Yeah, I got some like terms. I have a couple of x values. These are like terms. So 3x and 8x adds to 11x. Then I have to start solving it. What's next? Yeah, add 24 to both sides. I have $2 in my pocket, or I see something that costs $2. I have 24 in my pocket. So x is equal to 2. Oops. Agree? Is the problem done? What should I do with that 2? Yeah, I actually plug it into either of them. But which of those looks easier, the top or the bottom? Bottom, because what letter am I solving for? Y. So I get y equals 4. There was x there. X is no longer there, so what's going to go there? 2. Done. Done, done, done. What do you think? Impossible? I don't know. And you try it and you work it? I hope. All right, do me a favor, friends. Will you try number 2? And will you try number 10? I'll give you 3 minutes. Hey, Mason. Did you see my email?
Yeah.
So you know what to do.
I got most from, I think, actually all of the ones that you told me to get done.
Sweet. Bring them up here, show me, and I'll write me a note. I'll write a note. Huh? Thank you. Let's try number 2, see how we did. So this is how I would probably try and do it. So elimination is going to work nicely. Agreed? Why would it work nicely? What's going to go away if I add these together? Anybody? The y. That goes away. How do I know it goes away? Well, I have a positive y on one and a negative y on the other. Okay? So from here, If I combine this, I have negative 4, negative 2, both being x, so that gives me negative 6x. The y's are gone. 5 minus 5 is 0. Friends, what does x equal to? 0, because if I divide 0 divided by 6, I get 0. So here's my first answer. That's my x value. How do I get my second answer? Yeah, I'm going to take this, and I'm going to plug it in either to the top or the bottom. Now, friends, it doesn't matter which one you plug it into. Bottom one has 2 negative signs. Top one has a positive and a negative. I don't know. Top, maybe? Let's see. If I plug it in right here, what's going to happen here? That parentheses is where x used to live. What's going to live there now? 0. Negative 4 times 0 this week is?
0.
Good.
Ding, ding, ding.
If I add 0 and y together, I still get this. So I have 0, comma 5. That's my solution. That's my answer. Okay. Feel all right about that? And then, what was the other one I asked you guys to try? 10? Thank you. Number 10. Okay. It appears to be substitution for this problem, and of course it says it in the directions. But why would I choose to use substitution on this one? Yeah. Yeah, what am I going to eliminate? I mean, I would have to move the 2x, the minus 2x over. I could probably add them together at that point, but right now it's telling us saying, hey, this is what y is equal to. So I'm going to replace this y with the negative 2x. Now, this is where you have to be cautious. You have this so far. Where those parentheses are is where y lived. What's going to replace that? Negative 2x. Now notice, friends, in the green, I have the original problem less the y. And in the red, I have what the y is equal to in the other equation. Can you see where a mistake might take place here? You got a lot of negative signs, don't you? If I have two negatives, one after the other, what's going to result right here? What's that result going to be? Positive. Negative 3x plus 2x equals 2. Combine those together, so I get negative x equals 2. So what does x equal if negative x equals 2? What do I have to do to get the negative to go bye-bye? Multiply by negative 1. So I get negative 2 as my x value. Okay. All right. What should I do with this negative 2, my friends? Plug it in. Plug it in for x. Which of the two, the top or the bottom, looks easier to plug it into? Bottom. Do you agree? Cool. That was where x lived in the parentheses. Now it's going to be a negative 2. So negative 2 times negative 2 this week is going to be 4. Here's my solution. Okay?
Real quick, another error that I noticed, because I even didn't even recognize it, was if you were to put like 3x and then your parentheses here as 2x and like multiply that 3x, you got a different answer. You would have gotten 6x, right? So always make sure you have that negative and that you're bringing down what the original equation had and you're not missing something, okay? If your answer is coming out funky, that's probably why. So that's something you guys have to be really careful about, is those big negatives, because they'll come back to haunt you. So that's an error I saw. And I even did that myself. Like, I was like, oh, there's a negative in between. That was there.
Okay, so a few things. I need you to make sure you have the old workbook still. If you decided to be green over break and recycled it, come see me. Not yet. Okay? Because we're going to work out of that for 2 weeks. Is that okay? Sometime between today and 2 weeks from today, you need to go over to the bare necessities. And you need to get the CP Algebra 1 Semester 2 workbook. Okay? Yeah, it's $5. If you don't have the money to take care of it because of financial hardships, talk to your counselor. Your counselor gives you a coupon to go get the exact same book. Okay? But myself and Ms. Stone aren't here to provide you a book. It is your responsibility to get it. So whether you bring in the $5 because you have it to get it, or if it's financial hardship, you need to go see your counselor. We can't give you a coupon. Okay? That's not our job. Yeah.
It's by the IC Cafe now, right?
Yep, by the IC Cafe. Yep. And they got lots of candy in there too.
And since we don't have homework, what I would do if you do have $5, like on you, I would go get it today. Just so then you have it, you don't forget it, and you get it done.
Yeah.
You know what I mean?
What happens a week from today? Oh shoot, we need to order more books. So let's not be that class that has to go wait off